So today onwards, we'll see some recorded session on a linear differential equation with constant coefficient. Yes, we are at shortcut methods to find out a particular solution. So let me revise the formula today. Tomorrow we'll see few solved examples on it. Okay, the first thing that you should know that in LDE, capital D, capital D denotes d by dx operator, that is a differential operator, while 1 upon d indicates the integral operator. Okay, so whenever we come across d of some function, take a derivative, and when we take 1 upon d of some function, integrate it. Okay, now the formula for particular integral is yp is equal to 1 upon phi d of fx. Okay, so this equation is in the form phi d of y is equal to fx, then yp is this one, that is 1 upon phi d of fx. There are near about total 11 shortcut methods that we have for getting particular solution. Out of that, we just completed the first five. Okay, the first one is exponential function e raised to x. So whenever we come across e raised to x, replace d by a. Uh, okay, just we have to replace d by a in that phi of d, in this function of d, replace d by a. Now, when the base is a, that is exponential function with the base a raised to x, replace d by log a. Replace this d by log a. The last thing, when there is a constant, constant can be taken as a constant into e raised to 0 x. So replace d by 0. Replace d by 0. So that about the case 1, which is known as exponential function, e raised to x, a raised to x, or c. Next thing that we have is a trigonometric function, sin ax plus b or cos ax plus b. In some of the case, only sin ax is there or only cos ax is there. In such a case, we replace every d square by minus a square. Yes, remember, there is no replacement for d. D we have to keep as it is. Only d square we can replace it by minus a square. If the term of d cube is there, then we have to replace it by minus a square d, and d raised to 4 we replace by a raised to 4. So in short, replace only d square by minus a square and keep d as it is. Similar thing is in the hyperbolic function sine hyperbolic x or cos hyperbolic x. Instead of d square by minus a square, we replace d square by plus a square. Okay, that is the change. We replace d square by plus a square. So that about a hyperbolic function. Remember, the maximum examples in exam are coming in exponential and trigonometric function. Rarely the hyperbolic example will come. Okay, there is one more important thing that we have. Let we come to that point, and that is when we replace when we replace here uh, d by a or d square by minus a square. In some of the case, this phi of d coming 0. If this phi of d is becoming 0, in such a case you have to multiply by x. You can observe x is written before the operator, x is outside the operator, then differentiate the denominator, x into 1 upon phi dash d of fx. If that phi dash d is again 0, then again multiply by x, again differentiate the denominator. So we have to continue this process till the function of d becoming non-zero in the denominator. If it is 0, every time multiply by x in the outside and differentiate the denominator, and then replace either d by a or d square by minus a square, depending on whether it is a trigonometric function, exponential function, or hyperbolic function. So that about first three shortcut methods that we learned here. So yes, I will send 1-2 solved examples on these. So till then, bye. Thank you.